Is my screen visible?
Yes, Sanchit.
Okay, awesome. So I think let's start then. So yeah, thank you everyone for joining today's session. So I think we are in, as mentioned, we are in fourth session today. This is a week 4. We are halfway through with our bootcamp for cloud practitioner. I hope you guys are going through all the presentation which I shared so far, the video recording. You guys are going through it and understanding. And if you have any questions, even from the past sessions, please don't hesitate. Post on the Slack or reach out to me one-to-one in the Slack channel. I'm part of that. Or you can ask me at the end of this session or within the session. I'll be happy to answer this bootcamp for you guys. So please don't queries or questions, please reach out to me. With that, let me begin the session for this week. This session, we will be talking about AWS IAM, database, billing, and cost management. I'll try to cover in this session as well as the next 2 sessions that we can finish up more of the theoretical parts. So cloud practitioner, if we talk about, as I mentioned in the first session also, it's more of theory-based kinds of stuff it is, right? More of awareness, more of knowledge that you get, and you have broader understanding how exactly the cloud and AWS is about. The practical is very limited, but still I want you guys to have more practical knowledge also backed by certification. Only certification will not help you. So we'll try to cover all of the main topics which are required for the certification in this session as well as in upcoming 2 sessions. The last session what we have, we'll try to do more of hands-on. So the reason I'm calling this out now itself, so you have 2 to 3 weeks of time to set up and provisioning your AWS account. If you don't have it, so last session what we have, I want everyone to do the hands-on. So that's the reason I'm calling this out. I'll keep you guys reminding on the Slack as well as an upcoming session, but please don't get demotivated that this is more theoretical or when we will be doing hands-on. I have already planned the schedule in such a fashion that the hands-on is there once you guys have very good understanding and once we cover up the main agenda, which is the curriculum required for the cloud practitioners. And for the guys who are very new to the AWS, please do ensure that you have the AWS account spin up. And if you find any sites of issues and all, we'll take care of that. Okay, so with that, I'll start with today's session quickly. You know my name for any guys who have just joined us for the first time. My name is Sanchit. I work as a lead architect at Quantify. My outside Quantify, my hobby or my passion is to deliver different sessions across community with respect to specific services on data analytics and DevOps side, to doing certain of boot camps. So I've done this boot camp for AWS User-group in Dehradun, as well as, which is based out of India, as well as I'm doing a larger boot camp for Solution Architect Associate with a couple of other user groups. So, and this is the third one which I'm doing a boot camp. Along with that, I do also participate in larger sessions like AWS Community Day, Southeast Asia, AWS Community Day, Japan. So that's what I do in my free time, is to communicate, reach out to you guys, share my knowledge, share my experience, which I have gathered in so far from my IT industry. So that's what I do. Along with that, I'm also an AWS APN Ambassador, and I really present Quantify in the AWS group. It's APN Ambassador group itself, where we are kind of like mindset people from partner organization, where we share our knowledge, we share and we give it back to community and help community to give the feedback to AWS to build a kind of services, a kind of a platform which is more beneficial for all kinds of use cases and the customer. With that, let me start with the agenda. So agenda, as I mentioned very clearly at the beginning of the first slide. First, we will quickly recap. We have covered up many things in the last session. So I'll quickly recap what we have done, so you still get refresh from the last session. Followed by, we'll be having 3 new topics for today: AWS IAM, AWS databases, which is a very vast topic. I'll try to cover up that. And if not, don't worry, we'll continue in the next session. And the last, AWS billing and cost management. With that, let me start with recap of the last session. In the last session, we understood, we continue from where we left in session 2. In session 3, we started talking about EC2 autoscaling, where we quickly understood what is exactly autoscaling, how exactly autoscaling works, what is the benefits and all of this stuff. Ideally, autoscaling is of 3 things: what, where, and when. Just do remember, Each one has own acronyms to remember it. For me, it's 3 different things: what you want to launch, where you want to launch, when you want to launch. So do remember, there are different kinds of auto scaling are there, but this is the 3 different things which will help you to understand what to launch, where to launch, and when to launch. With next, we moved to load balancing, and we understood there are 4 different types of load balancer what we have. Network load balancer, which works on layer 7 of OSI. Then we have application load balancer, which works on layer 7, network load balancer, which work on layer 4. Then we have gateway load balancer for any sorts of virtual appliances like firewalls, intruder detection system from security perspective and all. And then we looked into the classical load balancer, the traditional one, which we used to have. So this way we understood it, and how we also understood how exactly your load balancer works very well or tightly coupled with case of your auto scaling. I would request admin if you can just by default mute everyone outside the organizer so we can continue it. And then we move to the very important topic, which was understanding how exactly the traditional compute era moved to the next level of ECS, and then how we moved ECS, what were the problem in case of ECS, we took it to EKS, which was like Kubernetes. So ECS, as we understood, it was more proprietary to AWS, where they tried to get that vanilla Docker kind of flavor in a very simplified form. And as well as Kubernetes, as we understand, is a more complex orchestration, which help in a master slave kind of a concept and gets more broader use case, more broader scaling. And we deep dive into that. Post that, we move to serverless. We started with what exactly is serverless, why do we need serverless, where exactly serverless works pretty well. And we also understood a couple of benefits of it, like greater agility, less overhead, focus, scale, flexibility, and faster time to market. We saw that serverless helped you a lot. We also understood in detail how exactly serverless is also called as event programming model, or how in detail Lambda works whenever there is any change or anything occurs in event source, right from an API call to any change in state of any AWS services, which maybe, let's say someone uploads a file to S3, someone writes a transaction to database, there's a change in the state, and that get captured to Lambda. And in Lambda, you write a connector code. That connector code, or whatever you can say, a custom code based out of different programming language, which is also think as like a function, and that function get executed and perform an action. So for any event change, you execute a code snippet that performs an action. So that was we understood in Lambda. We also understood SQS, which is application integration, like how exactly SQS is the oldest service of AWS, which was launched like over 10 years ago. I would say not even 10 years now. AWS itself has 10 years. So it goes more than above, and as well as how it helps you to buffer any sorts of request from a producer standpoint, and they can consume it, right? So as we saw in the first slide about auto scaling, how SQS works in collaboration for auto scaling, and this consumer is something what you can think of like the auto scaling node behind, which is based on the SQS message. And then we move to SNS. Like we understood, if you need any sorts of notification service, then you can have a kind of an notification, like you have the entire application to person, as well as application to person kind of thing what we can have. And we can send the notification to any of these services, or we can send it directly to human outside AWS, which can be in form of SNS, push, mobile push, or email. And at the last, we looked into step functions. Step functions is more kinds of an orchestration kind of a layer. Like if you have like a complex Lambda or chain around it, and you want to chain different Lambdas, you can have a kind of an orchestration. You can chain those Lambda and build more intelligent orchestration around serverless stack. So if you want to trigger any, sorts of SageMaker or machine learning model, training model kind of thing, or any sorts of big data pipeline, step function not only just integrates with Lambda, but it also integrates with EMR and all, and can help you to orchestrate that kind of a pipeline, your big data pipeline. So that was a quick recap from the last session, where we understood how exactly it works. with that, we will move to the next topic for this session, which is around AWS identity and access management. So first of all, AWS identity and access management. Before we go and talk about in detail what exactly is IAM all about, how IAM differs and all, let me quickly give you a quick one-liner about IAM, right? For like very simple definition, IAM is a security posture or the governance posture of AWS. Anything which you want to do, right from giving a permission to any sorts of user for any service, or you want to restrict any user to access any particular service, IAM is the backbone of doing everything. Right from you need permission to log in into AWS is also been provided by IAM. So IAM is the backbone when it comes to the security, when it comes to the entire governance layer, right? Like who should have what kind of access. So that's about, I would say, a short, quick description about IAM. And let's understand now in detail how or why, how exactly IAM provides different tools, utilities to achieve that, which I've just mentioned, like security and a governance posture. So IAM, if I go with the theoretical, IAM provides you fine-grained access, which will understand how exactly they do it. You can specify who should have what kind of access, under which condition, and you manage the list privilege. Always do remember, IAM works on a list privilege kind of a mode. What does that mean? By default, when you start working on IAM, it always works in a all deny mode. Like technically, whenever you launch any or whenever you deploy, which we'll see in the lab session, whenever you create any user, by default, the user is created without any permission. Like as and when you start, that person start working in AWS, start doing any work, at that time you start slowly giving the permission. It's our bad habit or not following the best practices that we always try to follow the shortcut and give that person an administrator. But technically, AWS always promotes that you should work in a list privilege fashion that only give the bare minimum or minimum amount of access which is required, not open the full permission. So that means list privilege. And if you see here, who can access what? That's exactly in 3 words IAM is all about, as I mentioned. Who means there are 2 categories what you can think of. In short, AWS as an IAM user or group of users, as well as AWS resources. There are 3 different personas you can see, like individual users, group of users, and AWS services. But in short, there is users and machine. Those are the broader level you can think of as who can access, like what kind of permission they do have. Can they do everything? Can they do specific thing? On what resource? On what condition, right? So that's exactly means, and at a high level, what is AWS IAM. As I mentioned very clearly about IAMs, right? So this is the same thing which will help you. So in case of IAM, here exactly you will see it splits into 2 things. One is the identity. The identity means users, group of users, roles. Roles are nothing but that is been attached to machines, and credential. Technically, credentials are also you can consider as kinds of a role or the permission, a short-lived kind of a permission or kind of stuff, right? Like how if you would have seen, if you would ever use any sorts of API, you have certain kinds of credentials, right? Like it's very simple. You would use a credit card, you have your PIN code. That's a credential. Similarly, when you want to use AWS API, the best practice is always to use IAM role, but certain people also try to use credentials, like temporary credentials, access key, secret key kind of stuff, which is not at all recommended. Or if you are using it for a given scenario, it should be very short-lived and rotated frequently. Those are the different kinds of credentials you can think as an identity. On the right side, there is permissions. Very simple to understand. Permissions, policies, and statements. We'll go very detailed like each what it means. But for now, just remember that on one left hand side, you have all the identities. On right hand side, you have all the permissions. Like permissions is where you define the boundaries. What kind of access and which resource. And if you go back, who is the identity. So that's exactly IAM is about. Now, when it comes to IAM, most of the enterprise, like if we talk about most of the enterprise or the big companies who are working on the cloud, what they do is they by default integrate their IAM with their single sign-on Active Directory, where they have their users already part of it. So it becomes very easy there. But when you have when you're using for personal, like if I talk about myself, my personal AWS account is policy driven, like username and password based. So there are certain norms or certain best practices where you should take care as a password policy, which is very important. So these are the couple of guidelines or couple of suggestions which AWS asked to implement, like require at least one uppercase, one lowercase, one number, alphanumeric. So please ensure whenever, for the folks who are going to deploy the AWS account, do ensure that you check and maintain. Just don't ignore it. This is for you guys. It's very important. So there are two things. One is a password policy and one is the MFA, which we will look in the upcoming slide. These are the two best practices, and I would make it more mandatory thing which you guys should enable it. And again, if you guys are not enabling due to some issues, we can take it in our lab session, but it is highly recommended that you should enable the password policy. Again, as I was talking about MFA in the previous slide, MFA is, let's say you have username and password, but it is very easy nowadays that you can easily hack brute force attacks. There are multiple different kinds of attacks where you can easily get into what kind of credential or what's a password is, right? You can easily hack. There you have an MFA, which is a layer above your username and password. So whenever someone ties, let's say even though your username and password get compromised, it should not be, but it get compromised. What's the second layer of defense? Here is a second level of defense, which is multi-factor authentication. Multi-factor authentication is just like, you can think is like a one-time password. So whenever you make any bank transaction, you enter your username and password. The third thing that system asks is, can you provide a one-time password? And that password, you get it in form of an SMS, which again varies from bank to bank. But that's how generally banking system or any financial system works. In case of AWS also, you can enable same setup. There is an authenticator app that is provided in the market. Instead of an SMS, you can open, you can just set up, you can pair it, like you can see the list of all the application. You can pair it by scanning the barcode. It's like how you do Google Pay. You can scan this barcode, provide the two different codes, and that's it. It's a virtual application which resides in your mobile, like how you have WhatsApp and all. It just resides in your mobile. And every next time when you try to log into your AWS, it will ask you, give me the username, give me the password. And once you give the password, it will ask you, hey, give me the MFA. And that MFA you can get from that application and give it. That application is within your mobile. So that is pretty sure that none of the people can get into it and compromise it. Again, this is a virtual MFA. There are hardware MFAs also you can do. Generally, enterprise, I've seen like very limited person do it because you need to maintain it. If it get lost, it becomes a problem. Like you can think of like something like how you have a barcode. Your fingerprint, thumb print kind of thumb scanner kind of a hardware device. Similarly, there is a very small device, electronic device, where you get a OTP code, like 6-digit code, which you can enter in the machine in the AWS console, and you can log in. But most of the people, I would say, broadly, if I put out a number, approximate 60 to 65% of the people uses virtual authenticator. But this is how you get a second layer of defense. Now let's understand how exactly the IAM policies are. So IAM policies, if you go on the first slide where we talk about the entire structure of it, on the left side, we had all the users identities. On the right side, we had all the policies. So policies in short define the boundaries, like on what kind of permission you have on which service. So that's exactly in short policy, and policy is written in a form of end of the day, it's written in a form of a JSON, right? So JSON or kind of a policy which you embed or tell AWS that given this particular user, given this particular group of users, or given this role, can only do X kinds of activity on a resource in Y kind of condition, in simple language. So that's what policy help you. Now let's understand how exactly policy or what different types of policies are. In every slide, you will see this is a common term or common line. In AWS, you apply the least privilege principle. As I mentioned at the beginning itself, least privilege means you always give bare minimum required permissions. Don't open up everything. Otherwise, it is very difficult to keep a control, and person can spin up all sorts of resources. You will have no control on top of it. With that, let's understand the different kinds of policies, what they have. So AWS by default, there are 3 policies that are there: AWS managed policies, customer managed policies, and inline policies. AWS managed policies are by default AWS when you launch a new account, or it's a very new account, you've just deployed it. There are a couple of policies which AWS themselves provide. which is specific on what kind of action you can do on a service. It does not have any condition in it, right? The default kind of stuff, which is AWS manage. Customer manage is something what you can define it and you can apply it. Inline is very restricted. Like customer manage, you can, or inline, the difference is in customer manage, you can use from a UI itself and you can design something. So let's say if you're not a very hardcore techie person, doesn't understand IAM, but still you want to restrict the permission, then you can do it with the help of customer manage. From the UI itself, you can assign with the help of GUID. With the GUI itself, you can do it. Inline is for more technical person, where you're doing some automation. As a part of that automation itself, you want to have inline policies. There you will see a kind of an inline which you automated and put it as a part of your entire platform, where you give very restricted kind of access. That okay, this particular identity, which may, as I mentioned, will have access to this particular API on a service, and also this kinds of action. Like if it has, let's say, kind of an MFA or those kinds of enable, then you can do it. Again, don't worry about it. This is for more to you guys to understand. When we'll do a practical, we'll show you exactly how this works. So that's about the inline policies and the managed policies, what you have around it. Okay. And let's understand how exactly this inline or this image, which is there, which has been broadly mentioned. So here exact the kind of a permission or policy structure is, right? So this is like a policy where you have principal, action, resources, condition, and policy. So this is form, as I mentioned in the beginning, this is like a JSON structure where you define very clearly. So as I mentioned in the past slide, if you go back, there is something called as principal, the identity. So this is the, you can think of as an identity. Like any person who's a root user becomes an identity. Action is a set, a kind of an action which you want to do on a particular service. So AWS is a service. This is a particular action which you can do on service on this particular resource. So this becomes more as a condition. So this is a very simple kind of stuff, and effect is kind of a, you want to allow or deny. So you want to allow this particular user to perform this action on this resource. So I think this is very simple. As you can see, the same thing. Principal, who, what, which, when. So this is as simple what we understood at the first slide of IAM. And this is how the IAM policy in general look like in a form of a JSON. Now, someone may ask me that, okay, hey, if I want to give a nested permission, then how I can do it? Okay, in case of nested, let's say if you want to have one more, this is a pure in a JSON format, it works, right? And this is a JSON array. Like any person who comes with some knowledge of JSON, you will understand this is a JSON array. So if you want to add one more, you within this curly bracket, you can give a comma and you can add one more kind of a JSON object where either you can allow, deny, or you can do any kinds of action which you want to do. But that's exactly what I was talking about, the policy structure. And again, you can make it more complex. You can make it more simpler. It's always important. You make it simple or complex, but end of the day, it should follow the list privilege. Like technically list privilege, like some people, I mean, most, not some, I would say, most of the people, what they do is they put it star S3 : star. That means all the actions on S3 they can do, even on a bucket. But this is the best policy which you can see. Why? Because you're not only restricting the person to upload and download the object on S3 bucket, but you are also specifying which specific bucket you want to allow that user. So that's very list permission what you're asking to user to do. So that's how the best practice of writing the policy it should be. Moving towards next, let's understand quickly how exactly the policy works. I think so far you understand a couple of terms, how exactly it is apply, deny, principles, actions. This is the flow chart. Like technically, let's say I instruct my AWS account. This is how you should work. What's a flow? What's a process? It will allow someone to access or deny the permission. So as I mentioned, AWS IAM always start with deny because it works in a list privilege. So it's going to deny at the day one. It's going to deny it. Then you evaluate and apply all the policies. So as I mentioned, let's say, for example, this is a policy what we want to apply to a user called as Sanchit. So we apply this policy. Now this policy will get parsed here. And in this policy, you will see, is this an explicit deny? If yes, the final decision is deny. You will say user does not have a permission. You will show an error or in form of an API that you don't have the permission to do. If it is not deny, is it an explicit allow? Like, are you allowing everything? Then final decision is yes. So in this case, if you see this policy, you're allowing, and what you're allowing, get, put, and this bucket. So this is allow, explicit allow what you're doing. So yes, the permission is granted based on the action and the what kind of resource you define. If it is not allow, then the final thing is default deny. So technically, first starting with, if you don't add anything, it's going to be deny. If you add anything, then there are two states: explicit deny, explicit allow. If it is deny, as simple, it's going to say deny. If it is allow, it's going to allow the user and take care of it. So that's about how exactly IAM policy works. And the important thing is not the process. You can say this is very simple, right? What are you explaining? It's very simple. But this is the flow in which AWS IAM works in same sequence. Starting from default deny, apply the policy, explicit deny, it first checks for explicit deny, then it checks for explicit allow. And if both are not there, then final decision is deny by default as a default case. So that's how the evaluation logic works. This is how the inheritance. One of the important thing of IAM is also inheritance. Let's say, for example, there is one user who's part of, let's say, 2 groups or 3 groups. So by default, the IAM will inherit it of all the 2 to 3 groups. Let's say, for example, Charles. As you can see, Charles is a part of developer group as well as auditing group. And here you can see David. He's a part of audit team as well as operation. So both the permission, when you say this will be union. So developer and audit, whatever they provide, both policy will apply to Charles, as you can see in the image. Similar goes to here, audit and operation, whatever the both policy are there, like whatever apply, deny, both will be applied on David. So in IAM, inheritance plays a very important role, which you have to understand that, okay, whenever a user or a group of user is part of 2 different roles, both the permissions will be applied to it. So let's say, for example, I've seen this kinds of a common mistake. Let's say audit team gives a deny that Charles does not have the permission to launch an EC2 instance, right? Whereas developer says you have the permission to launch the EC2 instance. By default, deny will hold a higher precedency and Charles will not allow to launch the EC2 instance. So that's kinds of conflict you will see many a times when you have one user or a group of people inheriting 2 roles, where deny will always take a higher precedency. How? Because if you see this evaluation structure, right? So if you see this evaluation structure, by default, explicit deny is the first thing which get evaluated. So if you see there is a EC2 deny, it won't even allow user to launch EC2 instance. So do remember that this is a very important thing where most of the people makes mistake around it. Moving towards the next is the IAM role. So far we understood IAM policy, starting from passwords, policy inheritance, policy structured. Now moving to the IAM role. So I think more now people are getting more mature, and I've seen, but still there are some proportion of people, what they do is they always use access key and secret key in their application code, right? Now, what it means is like access key and secret key, you can think more like as an API key, right? That API key, you can use it. So even though, let's say if you want to write a kind of a particular API which lists all the S3 bucket, you cannot do that from your machine. Your machine, you cannot attach an IAM role to your machine. You can attach an IAM role to any of the AWS services. So ideally what people do when they're working from the local machine, they generate access key, secret key and put it in their machine. The problem is not they put it into their machine. The problem is that is long leave. So if let's say that machine get lost or it get into hands of other thing, they can do the same action with help of access key, secret key, because either that will not be having the list privilege access or no one is frequently rotating it. So that's the problem, that you're not rotating it. There exactly AWS always promotes that at least when you're working in AWS environment, you should use IAM role. So same thing when you're doing on your machine, you can do EC2 instance and you can have IAM role. So even though if that IAM roles get compromised or something, first of all, AWS is responsible. I mean, technically under hood or under the table, AWS also temporarily provides access key secret key. So, but IAM role is a wrapper around that kind of an operational where AWS rotates. I mean, AWS generate the keys temporarily, rotate it, and whenever you fire or request for any sorts of, I mean, any APIs request the credentials, IAM role generates it on the fly and pass it on to that particular API. So all kinds of operational things which I mentioned when you need to do when you're working on your local machine is all encapsulated behind the scene by IAM role, and you just have to assume the role. So that is the benefit of using IAM role. And you can most of the time you can use IAM roles, right, across all the services. Let's say when you launch an EC2 instance, when you play around with Lambda, when you use any sorts of other services, you need IAM role to access that particular stuff. So that's more about IAM role, and anything which you are doing within AWS ecosystem, it's highly recommended that you do with help of IAM role. Now let's understand. I think so far you understood three things from me in this particular session. What is IAM authentication? Like you have one is via AWS. I mean, someone can get into the AWS console and can take care of it. That's one way. Second is somewhere can do CLI with the command line interface. They can take care of that one. And the third one is writing an API, right? You can do an API call and do it. But behind the scene, how exactly this things works, right? Let's understand. If you're using any sorts of this API or in sorts of any sorts of an authentication method, what's up behind the scene that works? So behind the scene, if you would see, let's say there's a John, which is a user, and he's trying to do the things with console. Very simple. You provide username, you provide password, and you provide the token, MFA token, as we understood so far, which is an optional thing. As I mentioned, even to log into your AWS console, you need IAM. So IAM is a very core and fundamental. So it goes to IAM. IAM validates it, whether it's the makes sense. I mean, this is exactly what is required or not. And then if it validates, oh, yes, John is an authenticated user. The password, what John has given, the MFA token, what John has given is correct. So John is authenticated to perform based on the role John assumes. So whenever John logs in or try to access the AWS console, there are two things that happens. First, John's credentials or identity is verified. So this is what username, password, and MFA token acts as an identity of John. Post that, AWS IAMs tag a kind of a policy or a role to John, that whether John is a developer, John is a part of audit team, or John is a part of an operational team. So that role get attached to John, and with the help of role, John can do anything which is defined in that particular role with help of policy. Okay, so that's the very simple flow. The same works here itself, but the difference is when you do CLI and API, you cannot pass username and password. You have to pass called as access key and access ID and secret key. They pass to IAM, and IAM authenticates this access key and secret key belongs to which particular user and what role that user has. Let's say, for example, this access key, secret key belongs to John. So now IAM will also validate, is this the valid keys? After validate keys, it's going to see what role John has, like developer, audit, or let's say operation, for an example. Let's say John belongs to audit. So then it will allow the CLI or API to fire any sorts of APIs for any resources which are defined in that audit role. So that's how this exactly works. So the difference here you can see is here John is providing username and password. Here the access key and the secret key have been passed. The problem, there are two kinds of trend which people should not follow. I've seen is when they are writing the CLI or they are developing an API. When I say API, it can be any Python, Java, .NET, Golang, any sorts of API you're working around. People get hardcode this access key and secret key, and then they deliver this into GitHub, Bitbucket, any sorts of code repository. The problem is simple logic is you will never commit your PIN code, right? You will never give your PIN code, credit card PIN code to anyone in GitHub. There's the same logic what you should always remember. It's not a crime to use access key, secret key, but with great power comes great responsibility. This is the same kind of a concept. You get access key secret key, you use access key secret key, but you have to be very mature that first you rotate that access key secret key every 30 days as well as or 60 days. It's not based on whatever you feel comfortable. That's one. Two, whenever you're working on access key secret key, do always ensure that you don't hard code it in your code. If you take care of these two things, then you are at least better. But ideally, AWS, as always mentioned, try to use more of an IAM role. So that's how in three of the way, as an user from AWS console, in form of a CLI, in form of API, behind the scene, how IAM plays a more pivotal role when it comes to the authentication. Now, there are certain additional tools which are there, which help you as your friend, as your trustworthy, right? Which you will understand now. There is something called as Access Advisor. As the name itself suggests, Access Advisor help you that permission granted to user when the services was last accessed. So if you see in the IAM console, from each user, if you see the access key, secret key, or any kind of stuff from user itself, they will understand what is the last thing that person has done, when it was done. So as you can see here, this particular thing, this code snippet, you can see this image. You can see this is for one particular user. This particular user access IAM from this particular identity, and it was accessed today itself, right? The similar kind of thing you can see when it comes to Access Advisor. Now you will see what exactly is the idea. I mean, why do you need this thing, right? What is an important of this tool? The important part of this tool or this particular utility is it helps you to analyze which user is using what kind of stuff. Let's say for an example, someone launched and very high end, like a graphical unit kind of an EC2, which we understood in last session, right? Session 2, that someone launched a graphical unit EC2 instance, which is very costly. Now, if you want to identify who is that user who launched it, did he launch it for some use case or incidentally? With help of this particular stuff, I mean, for sure you can look into CloudTrail, but with help of this identity, first you can identify who are the users who have used the EC2 service, let's say in last 24 hours. So that's how the security tools help you a lot to analyze what different kinds of stuff it is. Moving towards the next, the credential report. Let's say if you want to get more a kind of a detailed view, like how exactly on the account stuff, how things has been there, who have used, when this user was created, more this tool is helpful from an auditing perspective, like how exactly access keys was there, how many times it is rotated or not, in MFA is enabled or not, any kind of like one consolidated sheet, which gives you an entire auditing structure. Then IAM credential report is your go-to tool. Most of any sorts of auditing which you do, this is a common ask from the auditor. Give me the list of all the users. Give me if they have enabled the MFA or not, password is enabled or not, what kind of access they did it, when they did it last, are they using the rotation or not. So in this one sheet, or with help of the service or the features of IAM, you can easily download and get those all details. Here are a couple of guidelines I would say when it comes to the IAM. Again, these are the same things which we have spoken in all different forms across different slides. I've just consolidated my entire best practices in one slide, like starting from lock your AWS account, like root access is the very basic first user via which you create the AWS. Always, you should not use root access. Whether it's even MFA or not, you should not use root access. Save it somewhere, because if it gets compromised, there is no second way you can get your account access back. So lock down your root user. Second, create an individual IAM user. So as I mentioned, you should not give root account to anyone. You should create IAM users and tag that IAM users to a particular group and assign permission to that group. Grant list privilege. Configure a very strong password. We understood those password policies and all. Enable MFA. Create and use roles for giving permission to AWS services. Never share IAM users access key and secret key. Rotate your credentials regularly. Remove unnecessary credentials. Use policy condition, right? So we saw in the policy structure, under resources, there was a specific bucket that is as a condition. And at the last, frequently, like on a regular basis, which may be monthly, 30 days, 60 days, do an audit. Even if you don't, I mean, if your company is very startup, they don't have auditing structure in place, It's a very mandatory thing. You yourself audit and see who are the active users. Like most of the organizations where they have IAM users and password, the common problem is whenever a person lives in organization, most of the times I've seen people tend to forget to disable the account. Still, they are not part of the organization. They do have the access of AWS account. That's the biggest drawback of using IAM user and password when they have it, right? As a part of Active Directory, it becomes very easy because that's a central entity of your organization. So that's one of the reasons, as I mentioned, why most of the enterprise uses Active Directory approach. But again, do use audit permission auditing report on regular basis to take care of that. And here I summarize from IAM perspective, IAM users, IAM groups, IAM policies, and IAM roles. This is the four big topic what we have learned in the IAM. If you go through this IAM, go through all the slides, that covers most of the stuff, not from a certification perspective, even from starting your career in a cloud also, it will help you to understand. These are the basic thing which you will see when you start working on the cloud. I hope if you have any questions, please post on the chat. I will regularly look at the chat, and if there is any questions, I'll keep answering that. But I'll move towards the next session, which is also very important. AWS databases and warehouse services. Again, now many people, I think database is a very common stuff. Any person which is coming from computer science background, they know what is database, right? Database is a mean where people can store the data, organize the data in a tabular format. If I talk it in a very layman language, I assume there will be many people who are not even from com science. So for you guys, just think of it. Excel, or you consider this kind of a table representation. This is more like a tabular representation of information, which database can provide. Now, database generally falls into two types of buckets based on how they can organize the data or how they store the data, which we'll see in the upcoming slides. But for the people who are very new to the database, do remember, database help you to organize the information in a tabular format. Now that information always needs not to be like a kind of like very simpler. It can be complex. It can be a document which you can store. Now let's understand. Now I assume that you guys are very clear understanding what exactly is the database. Now let's understand in detail how exactly the database, or what different, why Amazon provides an RDS as a service. So technically, whenever you're working on any on-prem side of it, right, you are responsible for doing everything. Just give me 1 second. Yeah, so basically, why exactly Amazon RDS is a service which Amazon has invented, right? There has to be an ask from the market. So whenever you work on an on-prem side, right? On-prem is a physical server, data centers. As we talked in the first session also, you have to do everything. Managing the license, you have to operationalize it, you have to take care of it, patch it. Now it becomes very difficult. Let's say if I tell you guys that, okay, hey, can you work on SQL Server? The first question is, sir, how I can work on SQL Server? I don't have a SQL Server. I don't even know from where I can get the license. I don't know how to set up, right? Those are the common questions that you will come up in the head. There exactly Amazon comes up. You don't worry. I'll give you the infrastructure. You need SQL Server. You need Postgres. You need Oracle, or you need any sorts of database, right? Which is a commonly used. I will give you the database. You worry what you want to do on that database. Like, do you want to store any sorts of your report? Do you want to store as a credential for your website? Do you want to store the user information for your website? What do you want to do? You focus on that. I will give you the infrastructure and you pay me as you use it, pay as you go kind of a model. So with that, you are not responsible in the RDS. When you use RDS service of Amazon, you are not responsible for spinning up the actual hardware system, installing the database on it, maintaining the database, patching the database, or doing this within the hardware part, the security side of it. You're not responsible. You just have to define it, what or how much compute kind of an hardware do you need there. I mean, the virtual kind of thing you need, which we understood in EC2 segment also, right? If we go back, like the hardware, the virtualization is taken care by the cloud vendor. You only have to provide the type of EC2 instance, like what memory, what RAM you need, and what kind of an AMI OS. Here, in case of an RDS, the principle remains almost the same. The below complex part taken care by the cloud vendor. You only have to provide which kind of database you need and what is that compute, like what kind of RAM they need. That's it. So that's what AWS RDS simplifies it. And they provide different kinds of database common engine: SQL Server, Oracle, Postgres, MySQL, MariaDB, all different kinds of things they do, they provide, which is a commonly used trend in the market. And here you can see a quick different comparison, which I was talking about, right? Application optimization, again, as I said, application is very specific to customer. So customer has to do it. Scaling, high availability, backup, patching, software install, OS patching, OS installation, server maintenance, hardware, power, network, cooling. If you see in RDS, everything is taken care by AWS. In case of here, we assume that EC2 instance, which should not be done. But if you see on-prem, everything will be the customer is doing it. So that's a big difference where you see EC2 instance and RDS. And again, one small thing, always do remember, in case of the actual database server, when I say when you launch a database server on EC2 instance or on-prem, you have the capability to log in into that database. Login, I mean, not from a username, password, and query the database, but you can log in or enter into the actual database host. In case of RDS, you don't have that flexibility, because since AWS takes care of everything, you don't have that flexibility to enter into the host machine and see how exact things works. That AWS takes care for you. You can log in into the database, query the database, do any sorts of create, retrieve, update, delete, any kinds of operation on the database with very seamless and very flexible and a cheaper rate, which or cost effective way, you can take care of that thing. So that's what the thought process was behind the RDS. And now, I mean, now you'll quickly understand, after going through and understanding, you'll understand quickly how exactly the different engines of databases are provided by AWS on top of this framework. Just this exactly as I mentioned, Amazon provides different kinds of engine. The things what we learned in the previous slide about Amazon taking care of everything, and you just have to organize, design your database. That's exactly what you have to do. And different offerings of database engine are Amazon Aurora, MySQL, MariaDB, Postgres, Oracle, SQL Server. Out of which Amazon Aurora will focus in upcoming slide in detail, which Amazon themselves has optimized and are bringing up in the market. But rest of the stuff, like you see, most of the things which are used in the market are all provided by AWS in RDS service as an under one umbrella. And you can select any of this engine or any sorts of database type. The principle of Amazon taking care of everything remains the same. Also, let's understand a couple of things which RDS mentioned. I think we have already deep dive into the first slide itself. When it comes to backup, when it comes to snapshot, everything is taken care by RDS. There are two kinds of backup is there. One is an automated, two kinds of snapshot. One is an automated, one is a manual. Again, we don't have to go very deep into it, but generally these are the practice which we do when it comes to playing on the on-prem side of it. Both AWS takes care for you, and you have to just ensure that you enable it and configure it properly. Like for example, I've seen most of the people, what they do, retention is for how much period you want to save your backup. Most of the people give 0. Now that's a little crazy, right? How we can give 0 as there? If you give a 0, it's not going to take backup itself. So you just have to provide the right configurations. Again, it should not be 2 more. It should not be even 35 days, or it should not be even 0. Some optimal days between 10 to 15 days. So you have to provide the right configuration values. Rest AWS RDS will take care everything for you. So that's about backup and snapshot. Okay. Snapshot is kind of, and you can think of like, does not expire, and it's like more like an automated way of doing it. So backup is what you take care of it. Snapshot is more like an automated way, which runs in an incremental. Now, someone can ask me that, okay, if I have, let's say, 100 GB of database, 100 GB is use size of it. If every time, every day, if you keep taking that snapshot, first, the cost will increase because you are paying for the snapshot. Two, the problem will come up is the time to take that snapshot. There exactly, AWS has optimize the snapshot route. The very first snapshot will be a full snapshot, full scan of database. Next snapshot, which you configure maybe next day or let's say after a couple of hours, will be incremental. The only new changes over and above will be taken care of it. It's not going to be from the start. So that's why, let's say, for example, you have 100 GB. So first time it's going to take time, but any new thing which is launched after that, let's say you make only 5 MB or 5 KB of changes, it's only going to take the incremental snapshot of the new changes, not the one. So that's the advantage how RDS also have optimized this process. Moving towards the next is the Amazon RDS scalability and availability. So it's not only give you the best features and functionality, it also provides you the high performance part of it. Now, in case of when you talk about database on-prem or EC2 instance, you yourself are responsible for giving that performance, ensuring that database is up and running. In case of RDS, AWS is responsible for ensuring that database is available, and they do provide different other features on top of that that allows you to even scale your database across different availability zones. I assume by now you know what is availability zones, different availability zones, and still if you don't know it, I would request highly, please go to the first session where you will get this term again, different availability zones or different regions. By default, Amazon provides different features that help you to achieve that. The whole idea, the whole principle of giving that feature is to ensure that the system which you use works on high availability mode and is highly scalable. So scalable and available, these are the two principal things which Amazon works. That exactly they have provided two different things: read replicas, multi-AZ. Read replicas in simple thing. Let's say someone, if you focus from any application, right? What happens is someone writes into the database. There is only one or two applications which writes, and there are more of the consumer which reads the database. Let's say you have some API which reads the database. You have some dashboard database. I mean, you have some dashboards or BI like visualization charts, which always reads the database. But when it comes to write, there is only one or two applications which writes. So in that case, read replica is kind of an performance optimization where you get like a very different reader machine on our database, which can serve the use case required by the reader, and the writer can hit the one. So that whole idea of separating or giving a dedicated reader point is to give you the best in class performance, because somewhere people always have that mindset. Write operation takes more time. Read operation should be very real time. They need the data at the click of a second. Whereas if the write operation takes more time, even if it takes 5 minutes, they're okay with it. So with that same thought process, Amazon have provided the capability of read replica to make the read operation much more faster with very lower latency and give you almost at near real time. High availability is more from an availability perspective, where if you want to scale your database across different availability zones within the same region, and again, if you want to also, if you see an Aurora, if you want to scale out that database across different availability zones, different data centers, you can easily do it with help of multi-AZ. So those are the two things, scalability and availability. Amazon also do provides with a very easy way. As I mentioned, Amazon Aurora. Amazon Aurora is an offering with Amazon provides. Again, RDS also Amazon provides, Aurora also Amazon provides. Aurora is an optimized engine which Amazon has worked. So Amazon has optimized 5x the original MySQL, 3x the original Postgres. So whatever the performance you can get in MySQL, the 5 times more performance you can get in Aurora. The original performance what you can get in the in the Postgres engine, similar kind of a performance with 3x, 3 times more you can get in Aurora at cheaper cost with more other flexibility when it comes to the operational part of it. So that's how Amazon Aurora provides MySQL and Postgres in a very optimized fashion along with other flexibilities. So what I mean other flexibilities is, let's say for example here, if you compare to the previous slide, you saw there is only read replica. Here there are writer point, there are reader points, and there is custom endpoints where you can do for more of analytical workload. So that's first slide itself. You can see what different kinds of features they can provide, because they have self customized it, so they can customize it to their customer requirement in such a fashion where it matches and meet your requirement, right? So most of the people I've seen when they are talking about Postgres or RD or MySQL, they will always look forward, hey, can you get me to Aurora, or can we leverage Aurora? Because of the kind of optimized performance what Amazon provides at same or lower cost. Also, in case of Aurora, they given a serverless. I assume by now you guys know what is serverless, which we saw in the last session for Lambda. Similarly, AWS also provides a database in a serverless fashion, which is called as Aurora Serverless. So you're only, I mean, there is a one fixed price which they charge, but outside to that, whatever your consumption is, they charge you on that consumption. And the database is spontaneously available for whatever the operation is required. So that's the best thing which you can think of ever, right? And again, for Aurora Serverless also, there are the same two engine. One is a Postgres and second is the MySQL. So that's about Aurora, how exactly Aurora is beneficial and why people are moving towards the Aurora part of it. The next is the global one, Aurora Global, which they have extended further. Many organizations, or you can think of like you're building a WhatsApp. Now, in case of WhatsApp, you don't know from which part of the world your user is going to be. It can be India, it can be Bangladesh, it can be US, it can be America, it can be UK. Any part of your world the user are going to be. There, if you need to provide a kind of a consistent lower latency database, that's how Amazon Aurora Global works. It allows the user to take it or read the data from the near geographical location. So let's say, as I mentioned, the same concept in RDS, that when it comes to the read, people always accept that the read has to be very fast. The write can take some time. So similarly, when you send a message on WhatsApp, you always accept when you're typing it or message is going, it's okay if it takes some time, because you know it is network latency and all. But when it comes to your reading the message, you want the full message, even though that's a long message in one go. The same is the concept here. When it comes to the write, you can have the write as one primary region. The read can be geographically distributed across different regions. That's how the Amazon Global works. One thing you need to be very sure when you're using Aurora Global is compliance. You cannot store any form of data in Aurora Global. You need to be very sure that when you do an Amazon Aurora Global, the data which you're storing in the database is compliant, that it can be read in any part of the world. Like for example, there are certain norms in US are there that any healthcare data, any FinServ data, any specific data which gets generated in US needs to stay in US. In that case, you cannot use global. And if you're using a global, you need to restrict only US regions. So those are the couple of things you need to take care. But if you don't have any sorts of restrictions, then global is the best thing, where it can gives you high scale to build an application without really worrying about how you can, or you need to replicate the data again and again across different regions. So that was RDS and Aurora. I will just shift a gear a bit and help you to understand. As I mentioned in the database slide, there are two kinds of database generally are there: SQL and NoSQL, relational and no relational. I mean, there's a diagram there for the people from comp science. It is very easy for you to understand. But the people who are not from comp science, very simple. In the first slide, I told you guys, assume when you want to store the data in a tabular format, in a table, rows and column format, people do in a database. But there are certain kinds of data format where you cannot store the information in more like a tabular format, like a fixed table. Like each and every entry should also have 3 columns. They need a flexibility. Like they need kind of a flexibility. Each row can have a more number of column, less number of column. So that means no relation. You cannot have a fixed format of the table. The format keeps changing as per given a row. So that's called as NoSQL or non-relational, and one is relational. Relational means, relational is a simple, you can think of as a tabular. And non-relational means non-tabular. You cannot have a fixed structure around it. So this is a very simple layman definition. SQL versus non-SQL. Again, someone will tell me, hey, there are some other things are also there, like primary key, foreign key, partition key, sort key. Those are a different way to function. That's exactly correct. You're right on your part. But of the people who are very new to this session, this is a simple definition which helps them to understand. But again, any database guy, you guys are completely right. The way the relationship works across a relational table, the way it organizes the data in a given table, it's completely different or has different way when it comes to NoSQL. But the primarily difference is in NoSQL, you don't have a fixed table structure. It can blend, like as you can see here. Row 2 only has, let's say, you can think of like one unique key, then one sort key, and then only one particular column entry. It does not have like the second and the third. Whereas in the first, you have it. But if you see here, you need to have the fixed, even though you have null, but you need to be sure that you have a price and you have a description. There is no way all the rows needs to have it. So that's a very simple difference between SQL and NoSQL. Now, so far we understood RDS, we understood Aurora, which was part of the relational RDS, relational database system. Amazon also provides Dynamodb. Dynamodb is the NoSQL flavor which they offer, which is very fast paced. Which is a very fast pace. They provide NoSQL with very microsecond latency. So if you need any NoSQL database, most of the solutions uses Dynamodb because first of all, it's completely managed. Completely manages. You don't have to worry about anything. Like in case of RDS, at least you need to provide the compute, like what kind of RAM you need, what kind of memory you need. In case of Dynamodb, they also simplify that thought process. You just define your schema, like you kind of define what will be your partition key, what will be your sort key, what kind of index it is, and you have your table there. So that's much more simplified, not only from a use case or from a operationalization perspective, also the performance is micro latency. Like it gives you in microsecond, it can fetch the record. So the performance is very, very high. And there are other functionalities where you can see of Dynamodb is, let's say, for example, any record which you change in Dynamodb, whether you add new record, you update or you delete, you can send that to Lambda to track in a formalized event, right? So if you remember in the event modeling, we understood if there is any change in the resources, so you can track this change. If there is any change, even on the single row of a database, you can trigger a Lambda and you can process and understand with the help of Dynamodb stream. Again, you don't need to go that detailed, but just for your understanding, Dynamodb is a very go-to service when it comes to the NoSQL requirement. Again, there are other things also AWS is coming up recently, like other flavors of database engine, which also falls in NoSQL and all. But Dynamodb is a prominent one when it comes to NoSQL because it's very flexible to use. The performance is very good. And they have also now at this reInvent or 2021, they have also come up with additional way where you can optimize or save more cost in case of Dynamodb. Again, those things are not required for cloud practitioner, but just want to add, because when you talk about Dynamodb, many people will say it's very cost expensive. It's an expensive service. So just for those audience, just want to let you know that in reInvent, AWS has also tried to launch a couple of features which optimize the cost further. So that's about Dynamodb. Elastic cache. From the name itself, you can understand caching. If you have any kinds of performance optimization, let's say, as I mentioned, Dynamodb provides you in microseconds. So someone might come up and say, how I can improve the performance of my web application, of my RDS, right? I don't want to, let's say, I want to improve my performance in RDS. So you can have an elastic cache. This cache operates between your application and database. So you can read the data, even you can write the data to this cache, and you can also read and write from this cache itself. So that becomes very easy way, right? And faster. So the faster is cache stores the data in main memory. So whenever the retrieval comes, the retrieval is very fast compared to you go to database, extract the data and give it to application. So that's the different thing, right? So you can see this quick image. When you have an application, you get the response very fast from in memory, but when it comes to the disk, it is slower. So that exactly the cache comes into the play. Again, there are certain detailed things which you should see when you're working very real life on Elastic Cache. Things like cache hit, cache miss, read from DB, write to cache. Those are the different process, right? Cache hit. So, okay, very simple. If I go back, when I said application reads the data, it is not necessary that every time that data will be available in the cache. Certain times, if the data is very new, the app, you have to go back to the disk and get it. So it's not 100% of the time you can read the data from Elastic Cache. So that is the first one. If the data is present in the cache, an application gets the data back from cache, it's called as cache hit, which is this green line. Let's say if someone tries to read the data, some application tries to read the data, that data is not available in the cache. So it will be a cache miss. What means that data is missing from the cache. You have to go ask the disk or the database itself to get the data. So there you read from the database and write to the cache, the same thing where you write to the cache for the next load. So that's how it works. The very best example of any caching solution is YouTube. Any video which you stream, do you feel every time that video is going to be served from any server located in US? If you think so, yes, I'll tell you no, that's not the case. Every time a content or a video is streamed from a server which is local in your area. And if that video is not present, let's say if you go to any sorts of, let's say 1920s video, if that video, for an example, is not available in that particular geographical cache server, then it goes to the original server to get that video if it is available. So YouTube is the best example when you talk about the caching on a larger scale. So that's about the Elastic caching. And any sorts of e-com website, you pick up anyone, Amazon.in, pick up Flipkart, or you pick up any other e-commerce website. All websites do have caching in place. So even though you will see that by default, even you don't have that internet or you have very slow internet, the home page will load faster. But when you try to open a particular product and go in description and pricing, that page will be slower, but the home page will be faster because that comes from a cache. So do remember that caching is very widely used when you build any large scale application where reading or read intensive performance is very very good is required. Couple of things you can see, any sorts of BI visualization also uses cache. Like if you talk about Power BI, you talk about Tableau, Elasticsearch, they also do have cache internally. So that's how exactly you can also use Elastic Cache along with your application to improve the performance of RDS along with read replica, and those things for sure you have. Here, so far up to Elastic Cache, I would say, and Dynamodb itself, we finish up our database. This was, again, you can think of like an in-memory database, what we understood. Next is Redshift. Redshift, people generally think of as kind of a database, but it's not a database. It's a warehouse which can scale up to petabytes, like 1000 GBs, 1000 terabytes, sorry. It can scale up to 1000 terabytes. A petabyte large scale warehouse system or a warehouse, a kind of an offering which Amazon provides, is called as Redshift. The Redshift, underneath the engine, the database engine of Redshift is Postgres. So Amazon took the Postgres engine, they optimized it, they made it in such a fashion that it can scale up to petabytes of data with faster processing. They use something called as massively parallel programming execution, MPP. So they took Postgres, they took this fundamental of MPP and built a kind of a warehouse which is very fast, scales seamlessly, and gives you the capability to do more of analytical workload. In case of RDS or even talk about DynamoDB, you use more of a transactional, row by row kind of stuff. Redshift is more meant for analytical. Let's say I give you 10,000 records of student. If I tell you, give me an aggregated view, how many people scored about 70%? That's an analytical thing. Where if I ask you very specifically, who is the topper from that 1000 database, 1000 rows which I give you, that is more transactional because you will go to row by row and do it. When I talk about aggregation and summarizing the data and doing a larger aggregation, there exactly you do an analytics around it, where you identify trends, identify those kinds of other details, patterns and all, where you can help it. Redshift is very good services. We'll understand how exactly the Redshift ecosystem look like, what are the different kinds of engines it has, or the way it stores the data. But Redshift is not only just the warehouse, it also provides, recently Redshift also has come up with ML, Redshift ML, that also help you to do machine learning on the data which you store in the warehouse, right? So that's the best thing, like very minimum cloud, I would say. Or when AWS announced Redshift ML, there were no cloud who offers machine learning as a part of the warehouse. So you not only, you can see, right? You not only can have like kind of a data lake or operational database, you can also have ML tools, visualization, as well as data sharing. Like Redshift can also share the data. So those have the different kinds of high level features and functionality Redshift provide. But for your understanding, do remember Redshift works on a Postgres engine, which Amazon has optimized it. They are storing the data in a columnar format and offers massively parallel query execution model. So that's about Redshift. And again, the fundamental thing, it's not OLTP, it's used for OLAP, any analytical workload, such like warehouse. So Redshift generally, one is a Redshift, one is Redshift Spectrum. First, we'll look into Redshift. So this is how the Redshift structure or architecture you can think of, right? This, you can think of your different application, your app, and this is a leader node, the compute node, like similar master slave. This is like a master node. This is a compute node, the data nodes, which does the processing. Leader node is more from an orchestration, management, and those kinds of stuff. Compute node are more the actual ground players who perform the operations, get the data, stores the data, those kinds of stuff. So that's how the entire Redshift warehouse looks like. Whenever you fire any query, it goes to the leader node. Leader nodes puts to the compute node, extract the compute nodes based on how the data is distributed. So AWS also provides the way you can distribute the data across different compute nodes, which you can go more detail. I would defer it from this particular course, but you can get that in detail, how exactly the data is distributed. And with all that is simplifying, that simply means how Redshift distributes the data across different compute nodes. Amazon also understood there was a larger kind of a people in the kind of a market where they don't want to store the data into the database storage, right? Into the no EBS or kind of a database storage. They want to explore the larger infinite features provided by S3. So as we understood, right, S3 is very infinite and unlimited scaling. So there were a larger proportion of the people who wants to leverage S3 as the storage, which is also you can do with Redshift Spectrum. So Spectrum works in a similar fashion. Like if you see the previous slide. So if you see the previous slide, there is a leader node and there is a compute node, and then you have the disk. Here you can see the leader node, you have the Spectrum, and your disk is nothing but the S3. The whole idea here, what Amazon does is they separate two different things. They separate the compute, the leader node, and the storage, which is the S3. So you can independently scale your compute, and your storage is already infinite scaling with S3. So you can scale the infinite data which is stored in S3 with help of Redshift Spectrum. But do remember that one fundamental thing, even though your storage is in S3, still you need one leader node. Your leader node is the main brain. So it doesn't mean that is a complete serverless like Athena, which we saw in a S3 structure, S3 slides. You still need a leader node which reads the data from S3, organizes it, and gives a response back whenever user consider. So that's about Redshift architecture, and the Redshift Spectrum. The next, I think I'll quickly recap. I think we have saw in the S3, Amazon S3 session also. Athena is also a serverless warehouse. The difference between Redshift is, as I mentioned in Spectrum also, Spectrum gives you the capability to query the S3. Athena is technically meant to query the S3 data. Both can query the analytical side of it. If you want to do any OLAP workload, both are meant of it. In S3 Spectrum, you need to deploy the leader node. In Athena, you don't need, it's completely managed. The difference comes is when Athena also used for more larger kind of stuff. But when you need like completely larger workload, there exactly Redshift Spectrum is widely used. Athena is more on a ad hoc basis. Like if you need a kind of a warehouse which does not have very frequent ask, but whenever it comes like 5-10 queries in a day or so, there Athena can works very well. But if you have very frequent ask again and again, every minute, every seconds, then you should use Redshift. So that's a high level difference between Redshift and Athena around, even though Redshift Spectrum is there. And again, this reinvent, need not to say, I think that's a very best functionality which Amazon has announced is Redshift serverless. You'll see that detail coming out very soon. They also have that beta access available. You can use it. Like how they have Aurora serverless. Similarly, they have also used the Redshift serverless, which you can organize in, which you can log in into your AWS console and request for this. So that's about Redshift, and that's about Athena. Athena, as we have learned, is a quick recap. It works on a Presto. So we saw Redshift works on a Postgres. This works in a Presto. And with that of Athena, you can not only query the data which is sitting on your S3 with a SQL-like queries, you can also query different other databases, including you can also query Redshift with the help of Lambda in place. This is all called as federated queries. And it's completely managed and serverless in fashion. You only pay for the cost. The cost of Spectrum and the cost of Athena is still the same, $5 per terabyte of scan. That is also $5 per terabyte of scan, but you need to pay for the additional leader node. And you need to ensure the leader node needs to be scaled properly, because this is the core brain. So if you don't have a strong brain or driver, the performance will not be optimal. The last thing is around the glue in the database. So glue is not technically falls into database or warehouse directly. Glue is, you can think of more like a serverless ETL. So if you want to, let's say, so far I have spoken a lot about how to store the data, how to query the data. There is also a kind of a people who want to transform the data. Transform means I give you, let's say, date of birth, and I tell you, get me the age of it. And not just 1, 2, 10, 100,000. I'll tell you 1 million rows, right? What are you going to say? I am not going to do manually. I will write some program, a program which is very faster and done in an optimal fashion. That's where you do something called as ETL, extract, transform, load, or ELT, any fashion, but you do some sort of a programming approach to process that data. Glue is a serverless ETL that help you, or you can think of a serverless ETL service, which help you to run either a Python code or a Spark, like which is used in a big data world, like a distributed processing framework. You can use PySpark, Scala Spark, or pure Python in a glue in a very serverless fashion. Like how you had Lambda, where you can write your custom code. In glue, you cannot write a custom code in any language. First of all, you can write the code, but not in any language. It needs to be either in Python or PySpark or Scala Spark, and you can do any sorts of processing of data without really worrying about scaling of the compute and those kinds of stuff. And from an integration perspective, Glue can easily integrate the RDS, Redshift, Athena, or different sources even on your on-prem, and can write the data into Glue catalog in Redshift, in S3, in any sorts of other AWS ecosystem. So whenever any architecture which you pick up on AWS, talking about data lake or lake house, Glue is the core component of that particular solution. So that's about Glue. And there are other components you will see. Like Glue, you can think of like a broader umbrella, which has different services. Like there is a crawler, there is a catalog, you can schedule the events, there is a job which you do the transformation, and then you can extract the data from the source, perform the transformation, and load. You don't need from cloud practitioner perspective, but crawler is more like crawl the data. Like it crawls the data, understand what's the schema of that data, right? So crawler crawls the data from the data store, defines the metadata. Metadata means data about data, like schema, any sorts of other information, schema change, those kinds of things have been tracked here and defined. Transform job refers to data catalog to understand what is the schema of the source. And at the last, you can schedule it. So you can schedule, as I mentioned in the step function also, you can schedule it. Similar kind of thing you can do in Glue. If you want to run an ETL pipeline at every 2 a.m., you can run this. Or if you want to trigger a Glue job on every upload of a file in S3, you can easily do with help of schedule or an event kind of thing, which extract the data, transform it, and load it. So that's about Glue. And the last thing is the open search. Open search, technically, you can think of like an what we saw in Elastic Cache, but the difference is Elastic Cache is more like a caching solution, whereas open search is a successor of Elasticsearch. So there is a service which is widely used by AWS. So there is a service which is widely used as an open source kind of stuff, which is called as Elasticsearch. Capability to query the in-memory data, right, in a very faster response, which is used for log analytics or clickstream data analysis, right? Similarly, AWS has launched a successor, a service on top of that framework in a very optimized fashion and open source, which is called as Open Search. As the name suggests, you can openly search any sorts of logs, real-time application monitoring, or clickstream analytics, right? You can also do visualization, like people who have worked in the past in Elasticsearch. That is something called as Kibana. Here they provide open search dashboard, right? And internally, here are the things which you can learn about it. So there is something, things like you have the indexes. Each index has a shard, as well as shard. You can think of more like a subset of the documents, right? You replica, you store in the form of a subset around the documents. Then the cluster, node, index, shard. Index is more like logical collection of data. Shard contains sub data of it, and document is the actual data, right? So actual data, actual thing which you store, which stores in a form of a document, which has been contained like as a subset spread across in a form of a shard. Index is a logical folders you can think of, and node is an actual physical server where OpenSearch is deployed. Similar on the left hand side, you can quickly run through, right, how things work. Whenever you search or request for a search, it goes to node 2, which is the core brain, the coordinating node, right? The coordinating node requests all the data nodes, right? The data nodes are the actual one where they have the response. So whatever the response they get, node 2 concatenate all the response they got from all the nodes and give it back to the client, right? So let's say, for example, here you see search house. You want to search as a house. It will go to shard 1, shard 2, 3, 4, 5, which is, let's say, stored across 3 nodes. At the last, whatever the response it got from 5 shard, it has been consolidated by node 2, and finally it is given back to the client. So you can do this kind of stuff for partial pattern matching, partial matching of data very fast, and it's all stored in memory. So you won't even understand a fraction of a second, you will get the response. So you can think of this example as whenever you search any sort of e-com website, you search, right? I need a speaker. You see that list it pops up very fast. That list generally comes from Elasticsearch. It is very fast, and people, when you search a keyword called as speaker, this is how exactly it behind the scene it goes across the node, get the results where what different categories are available, and gets that response back in a form of the list on the UI. So that's about open search. And here we end a second important thing also from today, which is around the database. Now we will move toward the next, which is around the billing control, AWS billing and cost management. I'll take a pause of a few minutes. If you have any questions and queries, please do post in the chat. I'll be happy to take that out. So there is a question around, can you tell us about the role of an APN ambassador, to how to join as a cloud architect as a first job? Okay, for sure, I'll help you with the answer to this question. I'll take it up at the end. So please do remind me at the end. Okay. Any other questions? Okay, I think there are no questions. So I'll move to the next one, which is on the pricing calculator. So this is a very important thing for your exam perspective. Pricing calculator. Pricing calculator in short is like a static kind of a form. Okay. Before even you start deploying anything on AWS, let's say even if you deploy an S3 bucket or an EC2 instance, it is very important that you understand the cost, how you're going to use that S3 bucket, how you're going to deploy that EC2 instance. You understand the cost of it, right? So you can understand and wisely use that resource. There exactly, pricing calculator help you to think of it. Like you can think like how you have a normal calculator, the actual calculator device, or in a phone. Similarly, this is kind of an pricing calculator which AWS has built as an utility. You don't need an AWS console for it. You don't need anything. It's a public link. So this is a link which is available, right? You can copy this link. Even you can open it now. You can fill out what different services you need, what different proportion, and it automatically will tell you, hey, just to let you know, your monthly cost will be this, your yearly cost will be this. So it helps you to plan in advance how the cost is going to be, right? It is more important in AWS. Most of the people you will see whenever you start working on the cloud, most of the people will always be very cautious about the cost, which they should be. There is no doubt to it. But that people, when it comes to the approach perspective, everyone wants to follow a reactive approach. Reactive is the cost get increased. Now what should I do? Okay, the cost is already increased. You have already consumed. You cannot do anything now. The more approach should be more of proactive, that the day itself when the cost start increasing it, you get the notification, you get the alerts, so you can take a proper measures at day one itself rather than the end of the month. The end of the month is done. You can do better at next month, but this month is already done. So I, as in personally, my perspective has been always to follow more of an proactive approach, whether it is security, whether it's best practices, or whether it's cost. Again, there are certain things which you also learn and evolve, but always look forward as more of a proactive architect rather than reactive architect. So pricing calculator is that proactive approach which help you to understand even before you start deploying anything on AWS, right? Even if you don't know how you're going to deploy it, you know, I'm going to use EC2 instance. I'm going to use this class of EC2 instance, this instance type, this volume for this many hours. At least go in calculator and understand what is going to cost you. So that pricing calculator is kind of a actual calculator. You can see the screenshot where it helps you to get the monthly and annually. Again, you don't worry about the cost. It's a very high end dummy number which I've entered for your explanation, but this exactly cost calculator or the pricing calculator help you. And it's a free of cost. To leverage AWS pricing calculator, it's a free of cost and outside to console. The next one is the billing dashboard. Now, whenever a person who has launched an AWS, they have an AWS account, there should be some mechanism where you understand how much you have been billed for what services, what was the last month, what was the month before that, what is the current month trend. So billing dashboard is a one consolidated dashboard where it gets you all the features. You not only just get this different graph, different split, you can get much more granular report, service wise, AWS region wise, even the API wise. Let's say someone fired and get object API on S3, how much time it filed it, what is the cost associated for that each get API cost, that kind of detailed breakdown you can get it. So cost billing dashboard is a one consolidated place where you can get all those report, which we will understand now in upcoming slides. Billing alarm. Billing alarm is more like a reminders. Like you have certain reminders in your calendar or in your mobile. At 2 p.m. you want to do something. At 3 p.m. you want to do something. The problem of alarm is it will tell you at 2 p.m. itself. Let's say at 2 p.m. it tells you that you have to go and get something from market. But if you are 10 miles away from the market, it is next to impossible that you can get it from 2 p.m. So that is more like a reactive stuff, right? But billing is exactly how generally we do like an alarm in the morning. As the name suggests, it's more like an alarm, billing alarm that, okay, hey, just want to tell you, you have already consumed $50 of your budget. You have already consumed $100 of your budget. So whatever steps you add, it will give you the alarms. Now, generally people add different stagger mode, stepwise, like 25%, 50%, 75%, and then the actual budget. So similarly, at every step, you can get an alarm. But the problem, this is an old method to do it. But the problem of this method is, as I mentioned, it's a very reactive approach. Let's say you set a budget of $100. Okay. Now you get an alarm at $100, what you're going to do now? It's already consumed. You already consumed your budget in, let's say, first week of the month itself. There is no way to look backward. You need to increase your budget. So that's why it was not that proactive approach. It was more of a reactive approach, which used to look forward. But in early days, at least this was beneficial for the people to get that alarms. So what got changed? AWS come up with the AWS Budget Service. This is more sophisticated services. First, it not only fixed that reactive approach to be more proactive, but gives you more data points along with alarms. So it gives you more data points like what is your current, how much you have consumed as of today. It does a forecast with your budget. It does a forecast on the monthly level, current versus budget, forecast versus budget, and it helps you to understand in detail. Let's say, for example, if you see this first row, the budget value is $45. So it, and the forecasted is 56. So it compares that, okay, what is the current versus budgeted? What is the budgeted versus the forecast? And it gives you a very detailed point, which help you more proactively plan. Okay, that's one thing. Second, it's not only help you to plan on these services wise, but also help you to get some more additional coverage. So it not only gives you the additional features, but also increase the coverage. So it's not just only the consumption, like the dollar value, your billing, but it also helps you to identify things like reserve, saving plan, the usage, and the cost. So it covers all the 4 segments along with the actual values and all, right? And you can get this detailed kind of stuff, as well as you can use the CloudWatch alarm method, which we saw in the previous slide, in this way to set the alarms, right? As I mentioned, like different alarms at different intervals, you can set that up also. That's why budget is the go-to service now when it comes to billing. And even though if you're using for your own personal account also, things like MFA for IM, things like complex password, things like budget, you should for sure enable it so you understand it, because when you do an experiment on R&D, you don't have a track how much you're consuming and where are you consuming. So here are the best practices which you should follow. Cost Explorer, as the name suggests, exploration. It can help you to analyze the cost last 13 months, different region wise, different services wise. If you have multiple accounts, different account wise, you can analyze the cost and get more better visibility how and where are you consuming. So here you can see a screenshot of different trends that you can help to understand that how exactly my cost is looking like. Let's say in October, like if I consider the October itself from 16 type usage and all, as well as this is the default view or the default way of getting the reports. I mean, the visualization. You can create your own custom dashboard also. Like if you want specific kind of dashboard, how you can define the visualization. Similarly, with the help of this tag option, you can create your own custom dashboards, and you can need something, right? Or tagging wise, you need something. That kind of stuff also you can do it here. As the right time of talking about the tags. Most of the organization as a best practices allows tag. The tag is a way which you can track. So every company, there is a mandatory thing of tags. Tags is to identify or segment your cost user wise. Let's say Sanchit is using EC2 instance. Sanchit launch, let's say Redshift. So if they want to identify what is a monthly cost Sanchit consume, let's say $100. So they can easily track it with help of the cost allocation. So tagging, that's why is the best practices. And then you can have those tag which you have applied on all the resource as a converted into or enable it as a cost allocation tag. So you can automatically see what based on the tag value, what is the consumption. And again, tags are of 2 types. One is system defined tags. One is the AWS defined tags. So the system defined tags by default, AWS also provides certain kinds of tags which are AWS.prefix. User can also define the tags. So you can see user dot something. So you can easily identify which are the user defined tags, which are the system defined tags. So for example, here you can see AWS.created by user dot this. So easily when you see a tag, Something which is user colon tag is user defined, AWS colon means system defined. And you have to remember it. By default, user defined tags are not part of cost allocation tags. You have to enable it in the cost allocation from the billing dashboard. Then only you can use them as a filter. Then only you can use them as a filter to understand the cost, like this kinds of an Excel. So that's about the cost allocation. Moving towards the next is the cost tracking, right? So cost and the usage tracking is kind of a sheet. So if you remember in the billing dashboard I mentioned, if you want to understand in detail, like, okay, in detail, I mean is, let's say service, and on top of that service on the API, there you can get the detail with help of the cost and the usage report. So cost and the usage report, as you can see, it's not just EC2 instance, but even on the volume, even on the alarm monitor usage. So very granular kind of a report. If you need, you can enable cost and the usage report. Again, the best part is you don't have to write code and all. You just have to go to your billing dashboard, provide an S3 bucket and enable it. Every once in a 24 hours, AWS themselves will upload this report to S3 in the defined bucket. On top of it, as I mentioned in the previous slide also, you can have, since the data is already in S3, you can do Athena and you can build some dashboard around it. If you have some complex use case, or you can just simply download that Excel CSV sheet, comma separated sheet, and you can explore and understand how exactly the cost and other things have been defined. Two last slides before we wrap up for today is a support plan. So support plan is very important. So we understood billing and all, but how exactly AWS can help you, or what kind of help they can offer from some type of support from terms of technical advisory, support from billing perspective, support to increase the limit of certain services. There you see the support plan. There are 4 different layers of support or levels of support Amazon provides. By default, whenever you spin up an account, even if it is a very standalone account which you have deployed for your own practice, basic support is always included. So things like if you have certain queries around billing, you want to change certain billing things or payment thing, by default, you can talk to, you can leverage the basic support plan, which will help you to help around it. Along with that basic, you can have developer, business, and enterprise. It depends based on the use case. Most of the production accounts should have enterprise. Most of the times we also see people adopting in business and developer. The difference, now someone will say, okay, what's the difference? First, the common difference is basic is free. You don't have to pay anything for the basic plan. For developer, you have to pay, like as you can see the cost, you have to pay for the developer, business, and enterprise. That's one. Two, you also get a different SLA. SLA is the way, whatever the support ticket you raise, in what time frame it will get resolved, that SLA differs from the support level. So for basic, it is somewhere around like 48 hours to 72 hours, you can get it. Developer, business, enterprise has much more faster compared to basic. So that's around it. And the biggest difference that comes between business and enterprises, as I mentioned, most of the larger enterprise always use enterprise because of the access to the technical account manager. So someone from AWS helps you to review your account, the kind of best practices, the kinds of things which you do in your account, maybe architecture review, cost optimization, those kind of recommendation and advisory they can provide you when you go with the enterprise support model. So that's about 4 different model. Do always remember that basic is by default been there. Business, developer, business, and enterprise are the additional on top of it. Each support layer has a different SLA. So I have to encapsulate all the information here. Each one has a different SLAs around it and different kinds of features and functionality. So that's about the support plan. So if I quickly recap, we have learned a lot today. So I'll quickly recap what we have done. So we understood overview of IAM, who can access what. Then we understood the IAM is split into 2 big buckets, identities and permissions, the password policy which you should implement, MFA, what is exact the password policy, the structure of it, the flow in which the policy gets evaluated, and always remember, deny gets the higher precedency on allow, because of list privilege, and deny will be evaluated first. Inheritance, and the people always make mistakes. I mean, this is not part of your exams or certification, but do remember in real life, people keep doing mistakes when it comes to inheritance, like conflicting the permissions. Always use IAM roles instead of success key, secret key. The way IAM can help in terms of authentication in 3 different modes: the security tool, the credential report, and the best practices of the IAM. So that's about IAM. When it comes to the database, we understood what the RDS offering, which Amazon provides, backup, snapshot, scalability, read replica, high availability, those kinds of things, as well as we understood Aurora database, like what is Aurora, how exactly Amazon has optimized it, like 5x of MySQL, 3x of Postgres. Amazon Aurora serverless, which gets you more cost saving and gives you infinite power. It scales. You don't have to worry about the load and all of the stuff. Aurora global, and along with that, I made one note that please do ensure you cannot store any regulatory data, because you can read from any part of the world if you don't configure it. I mean, if you configure it global. And again, there is one primary writer region. I mean, there will be one node from primary region, and rest secondary region you can only read, you cannot write, as you can see in this architecture. At the master instance in US, so the write can only be performed on the master. The read only instance can be across any part of the world, which is only for read only. Then we understood the difference between SQL and NoSQL. Dynamodb, it's a NoSQL offering from AWS and provides a micro latency thing. So it's a very fast and widely used service. Elastic Cache to improve the performance of database further. Redshift, a warehouse offering from Amazon, which help you to store the data up to petabytes, and how we can perform more analytical workload. The two you can think of like two kinds of offering. If you want to store the data into Redshift node itself, this is the structure or the architecture is. If you want to store it in the form of an S3 and consume it, then this is the format of it is, where you can use Redshift Spectrum, and leader node can read with help of Spectrum. They can read the data from S3 directly without from the storage, and this is how they split the compute and the storage part. We understood Athena and the difference between Athena and Redshift. And then we also understood Glue. Like if you want to process the large scale data with Python or Scala, then you can use Glue. And at the last, we understood OpenSearch, which is an open source successor of Elasticsearch, which provided by Amazon, how we can query the data in a faster medium around it. And at the last section, which we move about the billing, the pricing calculator, you should always estimate or always understand or estimate the pricing it's going to take for the workload. The billing dashboard, the kind of different features Amazon provides in the billing dashboard, like billing alarms, which is outdated now and been replaced by Budget, which is a more sophisticated service for tracking, forecasting, or generating the alarms. Cost Explorer, which gets you detailed visualization and breakdown. Cost allocation tags, if you want to get much more breakdown based on your own custom tags, you can do that. Do enable, do understand or remember that by default, any tags will not be part of cost allocation tags. You have to enable it, then only it can be cost allocation. There are two types of tags are there: user defined and system defined, which is AWS defined. User defined will be always user : tag. AWS will be AWS : tag, like as you can see here. So that about the tag. The next thing is around the cost and the usage report, like how exactly AWS can help you to not only track the services, but even the cost on the API layer, like how exactly the different APIs can cost you, and what's a line item. And you can easily enable this by AWS billing console. Just put it into S3, enable this and give the S3 bucket, and by default, Amazon will store the results into S3 bucket once in 24 hours in a CSV format. Then we understood the support plan. Please do focus the support plan. Just don't skip it. It's very important for you to understand the support plan because that will also help you when you spin up your own account. So support plan by default basic comes out of the box, free of cost. The features are very less. And when you move towards the next support model. It's chargeable, but provides you more features and functionalities. Most of the enterprise uses enterprise support because they get an TEM, technical account manager, as a part of that support plan, which acts like your advisory service, which can help you to give suggestion, recommendation, and the architecturing best practices. The broader difference is the kind of an SLA in the support plan, and as well as the kind of accesses you can do. Like in developer, you have one primary contact, in business and enterprise, you have unlimited. So that's what we have from today's session. I'll take a pause here. Please, if you have any other questions, please post in the chat and I'll be happy to answer them.